reviewing for the test. But we can do the test either tomorrow or Wednesday. It doesn't really matter. So we can discuss. I would like to leave calculus tomorrow so we could do 6.5 so that we can test on Friday. But
are we just like, all we need to do for physics, like, before we leave is the test?
yeah, so if we take it tomorrow, we would be done with physics, and then we can use physics to do some calculus to offset. Because, like, this morning, Mr. Law asked if there were, like, if we needed extra days for AP. And I'm like, the only option is spring break or Saturdays. And I don't want either of those. But I'm like, honestly, like, since we can use physics, like, we're actually, like, pretty on pace with where we need to be. We really only have, like, a few sections left, I think, after this one. Like, it's...
Like, for the exam?
Yeah, like, what we have to cover. One, 2, 3, 4, 5, 6, 7 more sections. So... out of 2 different chapters. So, not really that bad.
Yeah.
Overall. So I was like, no, like, we're good. Miss Patton was like, I'll just teach on the way to senior trip.
No.
Can you imagine her grabbing the microphone in the bus and starting to teach?
5:30 a.m.
She would insist that she doesn't need the microphone.
Yeah.
Yeah, but on the bus, though, I think she would want it.
She would.
Might be the one time she actually uses the microphone.
It'd be funny.
She always insists that she doesn't need one.
Anyways, but we all were like, no, we're good.
Like, no.
I was like, we're fine. No biggie.
Pretty much, once we get to spring break, I feel like it's not going to be, like, I don't really have a lot left. It's just, like...
Spring break, there's only, like, 2 weeks after that before
it's kind of crazy.
the exams start.
Is this recording yet?
Yes.
Cool. How much of this is recorded? I mean, the conversation.
Just the last, like, minute.
From
Okay.
when I think it's from, oh my gosh, my voice. The water got stuck.
At least there's water. You need me to refill that for you.
I got it. I need to finish that first, though.
All right, these ones say find the total area of the region between the curve, because I'm assuming, looking at what you did before. Yeah, you basically have already been doing that. Okay, so what I need to do first is I need to take this and set it equal to 0 and solve for x to see if there's anywhere that this is equal to 0. So 3x squared minus 3 equals 0. So I'm going to jump straight to x squared equals 1. Add the 3, divide by 3. So then x equals plus or minus 1. So that tells us how I need to break up this interval. So I'm going to be going from -2 to -1, from -1 to 1, and from 1 to 2. Those are going to be my intervals that I'm dealing with. Because I've got to find, essentially, it's like the area above, the area below, and then the area above again, basically. Like, to find the total area. So, we do from -2 to -1. And I usually just put this out to the side so that I see which, like, area I'm dealing with. So we have the integral from -2 to -1.
Was that a pun?
Yeah. Of 3x squared minus 3 dx. So what is the antiderivative of that?
Something cute.
X cubed
Oh, yeah.
minus 3x.
Evaluated from -2 to -1. So this is -1 cubed minus 3 times -1 minus, and then I usually bracket this off, -2 cubed minus 3 times negative 2. So that's negative 1 plus 3 minus, in here that's negative 8 plus 6. So that's just a negative 2. So then plus 2 minus 1. So that's 4. So that's the area of that region, is 4. Now, from negative 1 to 1, switching colors so we can see where I switch to the next region. Same thing. Integral from negative 2, negative 1 to 1 of 3x squared minus 3 dx equals, so that's x cubed minus 3x, again, obviously, but evaluated this time from negative 1 to 1. So then that would be 1 cubed minus 3 times 1 minus. Now, if you already know what this is evaluated at negative 1 from up here, which would just be 2, you could go ahead and write that down, or you can just replug it in. Either way, it's not going to make a difference. So that would be negative 1 cubed minus 3 times negative 1. So I've got 1 minus 3. Negative 1 plus 3 is 2, so that's minus 2. So that ends up being a negative 4. So the area there is negative 4. And yes, obviously area is not negative, but we'll get to that in a minute.
Don't we have to like add the absolute values of everything?
But I'm not done.
Yeah.
Now I'm interval from 1 to 2. So again, I've already done the 1 for 1, so I could do that. And so I've got the integral from 1 to 2 of 3x squared minus 3 dx, which is x cubed minus 3x evaluated from, this is my fatal flaw, I keep looking at the stuff above and keep trying to write the exact same thing that was up there and realizing that I'm writing it wrong. So then I've got 2 cubed minus 3 times 2 minus 1 minus 3 times 1. So that's 8 minus 6. What is that? Negative 2, so plus 2. So that's 4 again. So now total area is the absolute value of each thing. So the absolute value of 4 plus the absolute value of negative 4 plus the absolute value of 4, which is 12. All that work for such a little simple answer.
It's a dozen.
I prefer a baker's dozen.
Doesn't cost a lot right now.
Mm-hmm. Like 9. I saw.
At Kroger, they're almost $9.
It
They're
was
cheaper at
Specifically
Sam's.
eggs, right?
Huh?
Specifically eggs, right?
Yes. I mean, a dozen donuts is expensive too. They're like $18 for a
Yeah.
dozen donuts.
I saw like a family pack, whatever, of eggs at Kroger. It was like $20-something. Like, no.
Why are the eggs
Yeah,
so
that's what I'm going to Sam's for, is to pick up eggs.
That's
But you can't put them on a pickup order right now. You have to get them in the
Are
store.
they limited too? Because like at
Probably.
Aldi, they had a limit of how many you could buy, and even so, they were like $6 at Aldi, which isn't as bad.
For 18 or for
12.
Why?
$6 for 12? That's more expensive than Kroger.
Yeah,
Why?
it's crazy.
Do they have an egg flu?
There's a bird flu,
Oh.
So sad.
and the chickens have revolted.
And
I was gonna say, isn't that
just
what
buying.
birds just do in past tense?
Yeah. I like getting like the egg. Have you ever tried the egg beaters? Like it's like in the carton. You get them from.
Oh,
Food Line.
yeah, I know what you're talking
It's
about.
like kind of like egg whites, but except it actually tastes like real egg because it's actually yellow.
So they're not whites at all.
No.
Is it liquid though?
Yeah, I use it to make French toast. It's so much easier You guys have to like be really nice. What?
Okay. So 46 wants us to find the area of the shaded region, which
This class is too funny.
basically,
Ooh, it's a giant L. What? It looks very sharp. Kind of looks like it would hurt to poke it.
I guess this isn't actually supposed to be straight. Though it very much looks like it is straight. I can't do it.
So does the
Good enough.
um,
All of this was given.
So, oh, is that like curved
It's supposed to be like this.
concave up?
Sure.
I-
Yes.
Okay. And the other one's concave down.
Yes.
Okay. I understand.
I mean, visually, yes. Mathematically, we would have to see.
I was asking for drawing purposes.
That's good, because I'm not about to go do the math behind it right now.
I mean, based on what the functions are, it should be that way.
Also, I forgot to grade your test. I took them home
Oh,
with me and then
no.
forgot they were in my
Oh man.
thingy, so I'll have them for you tomorrow.
Oh yay. Wait, you're disappointed?
She didn't want it. She didn't want me to grade it over the long weekend. And then we came back to school on Tuesday and I almost left them. And then I was like, nah, I need to take these home. I need to do them. And then I forgot because when I pulled my calculus stuff out, they weren't like with that. They were in a different folder. Because I had taken the review home for physics and like all this other stuff in case y'all like asked me for it so that we could like check it. Anyways.
I
So
did all
one
my
of the-
physics. I was very productive one night.
I did all of my physics, skipped some, but
You skipped some?
yeah, that's just 'cause I didn't know what to put.
Well, we're checking them today, so.
Can I just like put random answers then if I don't know the answer?
I'm letting you answer all of them. I'll wait with my paper. And I'll
She'll be
Okay,
like,
whatever.
I'll wait.
I'll wait. I'll
Okay.
let you take that one.
We'll swap and check.
Yes.
So, are these work?
Josh is getting really worried about this
What if
now.
this is our, you should make this our test grade. He's giving the mad eyes. I can see the fury behind his eyes. He's contemplating. Ew, that's scary.
All right, so when they give us this, what we're doing is we're basically taking these two functions and we're finding the area underneath these functions. But on the intervals that they occur. So basically, y equals the square root of x is occurring from 0 to 1. And y equals x squared is occurring from 1 to 2. So we'll take the integral of both of these with their respective chunks, intervals, and then we'll add them together to find the area like we did in the last problem. So instead of it giving us like an interval and we were finding all the different places it was like we did in the last one, this one obviously is they've given us two functions and then we're adding them together to make up the whole one. So we've got the integral from 0 to 1 of the square root of x dx. What would the antiderivative of that be?
It always takes me so long.
2/3 x to 3 halves.
Do you understand, Virginia?
Yes.
Okay.
Now
Just making sure.
it always takes, like, I understand it. It just takes me a second to.
The ones with the fractions take me, like, the longest for
takes me to
sure.
get- Yeah.
Because you have to think about, okay, what's the exponent? And then, okay, what do I need to do in the front to, like, get there? Yeah. So this just is what?
One.
Yes, 2/3. Because it'd be 2/3 times 1 minus, that would just be 0. So this is just 2/3. If I wanted to do this technically, I could do this so that we see it. Then I've also got the integral from 1 to 2 of x squared dx. What's the antiderivative of that? He's going to get you back before we even get to physics.
I know. Wait. There's something in front, right?
Mm-hmm.
1/3 x
Yep.
cubed? Okay.
Evaluated from 1 to 2.
It's a good thing I waited.
Did you get it right?
What'd you put?
I'll wait. That would have been. I really wish you would have answered.
Oh, I'm glad I didn't.
I
That was
would've-
funnier.
I would have confidently written it down too.
And then I would have erased a cookie point.
Be like,
See, it's really a good thing I didn't answer. Also, wasn't this the video last year where they got 3 cookie points?
Perhaps, I don't know.
Yeah. 3 in one video.
So 7/3 is the area under that part. So obviously both of these are already positive, but just for consistency, I'm still going to put them in their absolute values because if you ended up with one that's in negative, you would need to be aware of that. So we've got absolute value of 2/3 plus the absolute value of 7/3, which is 9/3 or 3. I'm gonna go back and circle these instead of. Come back.
You erased the 7,
I know.
but then came back.
I brought it back to life. Use that CPR.
that training.
I'm certified.
I thought she was about to say that tree.
I don't even think I'm still certified. I think it probably expired. by
I
now.
hope I'm not still certified because I don't know what I do.
Like, I'm certified, but you probably don't want my help.
The only thing I remember is CPR.
I just know that one scene from The Office where it's like, stay back.
Was it you I was talking about that new song that you can do that with?
Yes. What was the song again?
I don't remember.
Oh, I can't remember.
All I know is that you can do CPR to another one bites the dust, but that one just sounded insulting.
Whoever discovered that is one sick person.
No, the one getting CPR on is the sick person.
All right, this problem is quite long. But we're not doing all the parts. We're just doing part A, B, and C.
How many parts are there?
G.
Gee. Is there one like this one on the quiz, would you say? Like, is it something like this? Or more like.
Nothing more than what A, B, and C would be, but probably not. Because they give you a graph, that's the main reason it would be hard for me to give you this one. It says f is the differentiable function whose graph is shown in the given figure. The position at time t seconds of a particle moving along a coordinate axis is as follows.
Pardon me.
Meters. Use the graph to answer the questions. Give reasons for your answers.
I
A.
already figured out the reason.
The particle's velocity at t equals 5. You're gonna need your books open because you need to look at the graph.
Pull one out from over here.
Unprepared for class.
I didn't think about it.
Well, I did. I usually don't think about these things.
Do you know what page it is? Or is it different?
308.
I was better than that. Ew. Oh, goodness. Oh. It's so lumpy.
So we're basically using the fundamental theorem of calculus part 1 for this. So if S is equal to this, then we're looking at S prime of 5 which is equal to F of 5 and so at 5, what is the Y value?
2.
So this is 2 meters per second.
Is that it?
Yep. It's interesting because the book says units per second, but they clearly state in the problem that we're in meters. So I'm putting meters per second. I feel like I broke Josh.
Wait, when? Why? How?
Case in point.
How did you break
Yeah.
me? Like before you broke me, how did you break me?
What?
Exactly.
It's ever since you
Error.
that 1/2.
404.
What is going on with him?
Okay.
Stop.
Is the acceleration of the particle at time t equals 5 positive or negative?
Negative. Maybe.
For some reason, my brain registered you saying t equals time. So t equals 5. And I agree with you.
So the second derivative of position is acceleration, which is the same as the first derivative of f. So I know that the slope at t equals 5 is negative, so that means the acceleration is negative. I can't spell. Or I can't write, I'm not sure. I'm gonna blame that on my finger though.
So, how we're taking like the derivative of each, like, I'm just confused. Like, it's S prime of 5. Like,
It's the derivative of position,
okay.
but this is the antiderivative.
Oh, okay. Okay, that makes sense.
It is kind of weird to think
Yeah.
about though.
I have a
Like,
random question.
I might have a random answer.
So, you know how we have S, and we have S prime, then S double prime? What would have come before S?
Nothing. Can't have
So-
anything before position.
I thought she was.
I mean, R comes before S, but
Ever.
okay. What is the particle's position at time t equals 3?
Maybe I could have asked about f of x instead of just s.
E of x.
F of G of H of X. That's my favorite one.
They always hate when I do those.
I hate that.
But you should know it's your favorite, so
All right, so the first part is very clearly a line. F of x equals x.
What if there are very minor fluctuations?
Up to
between
time,
each
I can
dot?
tell that there's not because the points are on the graph. 1, 1, 2, 2, 3, 3.
No, I mean in between the points. Oh.
So,
Cut along the dotted line.
S of 3 is the integral from 0 to 3 of f of x dx. Because of what we just said, this is the integral from 0 to 3 of x dx. So the antiderivative, see if Josh can prove to me he actually knows what he's doing.
1/2 x squared.
From 0 to
Okay.
3.
Oh, I was right. Yeah.
And remember, when we just have a constant, I can take that and put that out front. So 1/2 times 3 squared minus 0 squared is 9/2. All right, so what was the last problem you had? Okay, and then don't hate me. 21, 25, 29, 33, 35, 43, 45, and 49.